Uh, Thank you very much, Liam. And my name is Yixin Liu. I'm a PhD candidate from Public Administration Department in Florida State University. And this paper is co-authored with Chao, who is from Guandong Research Institute of Water Resource and Hydropower. So today I'm gonna talk about the governance in interjurisdictional natural resources. Let's start. So first, look at this map. This is our study site. So there are two major cities in Guangdong province in China here. One is Dongguan and the other is Shenzhen. These two cities are very famous in China. They are neighboring cities and they are the core area of the industry in China in the high tech. So all of the iPhones you are using probably are made from these areas. So it take a great advantage to the um, um, economic development in China, but it also has a very serious water pollution problem. There's a river lay in the middle between these two cities. So we call it as a Maozhou River. So the problem right now is that neither Shenzhen or Dongguan want to take further steps or more efforts to improve the water pollution problem in this river than the other city. So it is a very classical example of the tragedy of commons. The interjurisdictional river, Maozhou River, is face a tragedy that neither the city want to take more actions about this. So based on this situation, we want to ask a research question, which is how to motivate the interlocal collaboration for water pollution control in this kind of cross-boundary areas. There's some theories in the public management to explain how to improve this. So there's different modes of network governance to motivate local actors in the network to collaboration together. So first is we call it as a participant graph network, which is very similar as the case I mentioned before, the Shenzhen and Dongguan. So these actors, these cities, they are collaborate with each other voluntarily. So there's no any principle, any other things among them, but they just voluntarily to collaborate each other. But there's also another more centralized form, which we call it as a lead organization. So one of the city may serve as a lead organization to share it maybe has much more power and resources than other cities, so it can lead other cities together to governing the interjurisdictional resources. Also, we can have an imposed authority here. We call it as network administrative organization. So it has more power and resource again to coordinate and collaborate the cities, the subordinate cities together to solve the problem together. Based on this different structure of network governance, so there's a question, is that which mode is most effective in governing the commons? The current study is focusing on these two modes. We want to compare the effectiveness between these two modes. So as I mentioned before, the participant governed network is a self-governing network. So it relies on the actor's self-governing communication. So it requires a high level of common trust, but it also fails when the organizational interests conflict with the network level shared interest. Different than the participant governed network, the NAO model can shape policy to reduce conflicts among the network actors. It simplifies the action process, and it also can formalize the coordination mechanisms. It has a power to monitor the network for performance and minimize the opportunity behaviors. Finally, it provides external resources to subsidize the network members, which improves the incentive and competency in the network level collaboration. There are a lot of studies talk about these different mechanisms of these different network modes, but of the measurement of the outcomes, what we know actually are the organizational level outcomes and the network level outcomes. But the previous studies, they really to touch I call it as the age level outcome, which is at the cross-boundary areas, how the collaboration can affect the cross-boundary areas. So that's actually my central research hypothesis are built on this. So we assume that when the participant governing network transformed to network administrative organization, the environmental outcomes in the interjurisdictional area can be improved. To test this hypothesis, I use a very recent policy reform in China. We call as the river chief system. It started at the end of 2017. So it requires the intercity rivers to shift its responsibility to the upper level government leader, which is the provincial governor, as the chief of those rivers. So the provincial governor and his team, his or her team, which as the departmental agencies, they coordinate the collaboration activities with the subordinate city governments together to manage these interjurisdictional rivers. The empirical strategy we are using here is a case study. So as I mentioned before, these are a very small region between two cities. There are 14 river sites in our sample. One is intercity river and 13 are inner city rivers. So based on the Chinese government's requirement, their record, there are six different levels of water qualities. So it categorized as 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and poor fives. And all the river sites in our sample are categorized as level poor 5. So they have a common goal to move from level poor 5 to level 5. And we have 24 time series points monthly data from 2017 before the policy implementation and 2018 after the policy implementation. And we also have 3 water quality indicators, chemical oxygen demand, ammonia and nitrogen, and total phosphorus. So it is a very, I think it's a suitable case for us to use the synthetic control method since we only have one treated unit and we have multiple control units together. The only difference, theoretically speaking, the only difference between the control units and the treated units are they whether or not receive the responsibility shift from the local government to the provincial governors as the river chief. And all these river sites, they located in a nearby watersheds, so they have very similar characteristics. So based on this information, we build the water quality, which is a pollution index by the Chinese Ministry of Environmental Protection. We use the actual pollution level of each pollutant divided by the standard target standard of the pollutant and average the number of the pollutants to get the equation below as our measurement of the outcome. So this is our raw data before any matching. So the green line is the treated unit, is the interjurisdictional river site. And the red line is the average water quality, pollution index of the control units. You can see that before the policy implementation, the treated unit has a higher level pollution index than the control unit in average. So the key point to make the synthetic control method happen is that we should have some covariates to construct the synthetic control counterfactual. So the covariates we are using are from 2 parts. One is socioeconomic predictors and the other is environmental predictors. From the socioeconomic part, we include GDP and government revenue and government expenditure, and also the population density of the area. From the environmental side, we use the river flow rate, land use for industrial or agriculture, and the seasonal water quality from 2017. So based on this data, we construct the synthetic control unit, and we can compare the synthetic control unit, the treated unit, and the donor sample average in this table. You can see that the characteristics between the synthetic unit and the treated unit become much similar than the donor unit, donor sample. So it means that our synthetic control method is successful. So here is our main finding. So after the policy implement, the water pollution index reduced dramatically from the beginning of the policy implementation. And the effect size is larger at the beginning and at the end of the implementation period, but it's not very large in the middle of the year. So in average speaking, we summarize the average treatment effect in the treated unit in the post-intervention period. So the pollution index reduced by 36%. The synthetic control method, the inference of the synthetic control method is relies on the placebo test. So we have this figure here. What it means is that we use the reassign the treatment to all the control units as the placebo test to see whether it can reproduce the similar effect as the treated unit. As we can see here, that the treated unit actually has the largest effect size among all the units in our study size. So it means that probably it is significant in statistically speaking. The similar idea I can also show in this graph, in this figure. So we test the pre and post period mean square prediction error ratio to indicate that the water quality gap between the treated and control unit increase in the post-intervention period. So what can we interpret this is that the effect size of the treated unit is larger than any of the effect size of the placebo units. So if someone assign the treatment to this data randomly, the probability of obtaining the NSPE ratio as large as the inter-jurisdictional river is 0.07. And in the synthetic control method, this is our p-value. So based on these results, we have some implications and some limitations here. First, the NAO model, which is the RCS policy in China, in our case study, is a better strategy to improve the environmental outcome in the cross-boundary area than their previous used participant Gulf networks. But there's also a problem here, is a concern there. The pollution control is unstable during the implementation year. So actually this is a open questions for us. So one of the possible reasons may be the importance of the annual performance in the central credit system. So the local officials, they care more about their promotions, and their promotions is largely based on the annual performance of their different indicators in environmental or economics. So maybe they want to improve the water quality for the overall performance of the year, but they are not very careful about the monthly performance of each month. We have some limitation about this study. So first, we do not have we have not tested the internal mechanism of the RCS. So it is we only test the overall effects of this pattern, but we didn't test whether which of the mechanisms are actually affecting this pattern happen. For example, what kind of communication strategy they are collaborating together, and what kind of monitoring strategy they are doing to affect the water quality improve. Second, the limitation we also have is that the sample size is quite small in this study. So we have a small observation, and we also have a very small time series. So if in the future we can put this into a macro level, in the national level, to see whether this effect can be held again. So maybe we can have more comprehensive idea of what's the NAO model and what the RCS can provide us. Finally, because China is an authoritarian regime, so the political institutional system is very different than the democracies. So a lot of policy are very coercive. So maybe there's very different than the other democracies experience. That's why maybe we can, if there's a experience, there's an opportunity that we can replicate this study to other countries, other democracies, to see whether these findings can be held. So these are all the contexts I have today. Thank you very much.